For the following sequence, state the next three terms. So let's start there. So what's happening from term to term here? What's going on? You might think at first it's adding the same number. If you subtract these two, you'd get 42. So that maybe it's adding 42, because that will get you from 21 to 63. But if you try that again, if you add 42, you're not going to get 189. That's not it. It's not adding the same number every time. So what could it be multiplying? What times 21 is 63? If you divide on your calculator 63 divided by 21, you'll get 3. So maybe it's multiplying by 3 every time. Does that work for the next one? What's 63 times 3? Yep, it's 189. Check your calculator again. Times 3, yep, it's 567. It's working perfectly. It's multiplying by 3 every time. So let's do two more. 567 times 3 on my calculator. 1701 times 3 again. Getting 5103. And times 3 yet again. 15,309. Okay, so what's a formula? Well, let's go down first off. Let's go down to here and figure out whether this series of numbers, sequence of numbers, is arithmetic or geometric or neither. So, arithmetic is when it's adding or subtracting the same number each time. Geometric is when it's multiplying or dividing the same number each time. I'm not going to go into quadratic. That's a little bit different. But let's take a look. Which one is this? Where we're multiplying the same number every time. We're multiplying. So this one's geometric. So that means we can use the geometric formula. So what's the geometric formula? The geometric formula, bring it up here, is, maybe I should give it a little more room up here. Okay, so the geometric formula is A sub n equals A1 times R to the n minus 1, where A1 is the first term, R is the ratio or the jump from term to term. So therefore A sub n is A1, first term. What's the first term? 21. Times R, what's the R? What's the ratio? The jump. It's times 3. We call it the ratio because 63 divided by 21 is 3. If you take the ratio, or if you took 189 over 63, if you take any term and divide it by the previous term, same thing. If you took 189 divided by 63, you'd still get 3. So it's the ratio between two terms. It's the jump, so that's 3 to the n minus 1. So there's the formula, 21 times 3 to the n minus 1. That's the formula for finding the nth term. That'll find you any term along the way. Out of interest sake, let's just see it work for a second. Like what if I plugged in for n there? What if I plugged in, I don't know, let's find what is this? This is the, let me get this out of the way right here. This is the first term, second term, third term, fourth term, fifth term, sixth term. This is the seventh term. What if I plug in like a 1? I'll get 21, 3 to the 1 minus 1. So the first term, I plugged in a 1 there, right there for n. That's 21, 3 to the 0. And what's 3 to the 0 power? So this is the first term. The first term will equal anything to the 0 power is just 1, and 21 times 1 is just 21. Sure enough, that's the first term. What about the 7th? Let's just jump to the 7th. Will this work for the 7th? 21 times 3 to the 7 minus 1. Plug in 7 for n. What do you get? The 7th term, this formula is predicting that the 7th term will be 21 times 3 to the 6th, right? 7 minus 1 is 6. Use your calculator. It's saying that the 7th term will be 21 times, and then 3 to the 6th, I'm doing it on my calculator. I'm getting 729, and then times 21, it's predicting that the 7th term will be 15,309. Sure enough, that's exactly what the 7th term is. So I'm just proving to you that this formula really is working. It'll give us any term now that we found it. There we go.